Students, I'd like to do one problem for you out of section 4.1 where I will discuss the first derivative test. Now, this problem came off your notes. If there are any other problems that you'd like for me to do, either a PowerPoint demonstration, a video, or perhaps just write out the solution for you and post it on Blackboard, please let me know. Now, the choice of which of those three things that I'll do, of course, is up to me. It depends a lot on my time and the nature of the problem. But please, I always want you to ask if there is anything that I can do to assist you in your understanding of calculus. I'd like to do a first derivative test with you with a more complicated than normal, or more complicated than average, shall we say, function that we have to deal with here. So in this case, I'm going to start by doing the first derivative. Now, the first derivative here is somewhat complicated because we have a product rule right off the bat. So let's talk about that. The product rule means we take the derivative of the first, which would be x to x, times the second, the derivative of ex is just ex, plus the derivative of the second, which is my e to the x again, it's its own derivative, times the first. Minus, now we got to take the 3 off to the side. The derivative of e to the x again is just e to the x, and then we just bring down the negative 3. So this is the first derivative, but it's not quite the form I want it in. It's not in descending order in particular, so I do that in order to make it easier to factor. So there's the same function in descending order, which means the highest exponent first. And now I will factor. I'll do that by factoring out my common term, which is an e to the x, and that's what I have here. And now I have to factor the trinomial. To factor the trinomial, I will leave that up to you. But there is my trinomial factored. Now, what I didn't put on the paper is I didn't set this equal to 0. Now, the deal is, if the product of these three things is equal to 0, then frankly, one of these needs to be equal to 0. So let's go ahead. E to the x can't equal 0, no matter what the power is. Even if it was 0, e to the 0 would be 1. So this is not the issue. The issue is one of these two factors has to be equal to 0. In other words, either x plus 3 equals 0 or x minus 1 equals 0. Subtracting 3 from both sides means x equals negative 3. Adding 1 to both sides leaves x equal to 1. So we have a critical point at either negative 3 or 1. Well, actually at both, not or. So the first thing I need to do is to graph this out, or map it out a little bit here. And there's my horizontal graph. I'll put a line over here at negative 3 and a line over here at positive 1. And I've got to figure out what's going on in each of these three regions. So I have to pick a point in each of those three regions. I'll pick negative 4, 0 of course is the easiest one, and positive 2. So let's see what's happening at negative 4. When I plug negative 4 into the derivative, and you'll recall the derivative again, which we took up here, when I plug in a negative 4, I get e to the negative 4 times e negative 4 plus 3 times negative 4 minus 1. If you do the calculation, you actually get 0.092. But the important information is it is positive 0.092. Of course, what we're saying at negative 4 is it's barely increasing, just a little bit. But the important thing is it's increasing. So it's going uphill slightly before negative 3. Now let's plug in the 0. And I get e to the 0 times 0 plus 3 times 0 minus 1. And calculating that gives us a negative 3, which tells us that at that point it's going downhill. And I've sort of misrepresented that. Everywhere between negative 3 and positive 1, it's going downhill. So it was going uphill from negative infinity all the way till it hit that critical point at negative 3, at which point it turned and started going downhill. That automatically means that this point at negative 3 is a maximum. Now let's figure out what's going on at positive 1, or excuse me, at 2. And I put in 2 into my function, and I get e to the second times 2 plus 3 times 2 minus 1 gives me 36.945. Now again, that kind of indicates that it's going up very steeply at that point, but the thing I want you to notice is the important part is it's positive, so it's definitely going up. So it was coming down between -3 and +1, bottomed out here at a minimum point, and then started shooting back up. So at this point right here, at +1, I have a minimum value, and at this point over here, at -3, I have a maximum value. Technically a local maximum and local minimum, which we will talk later about in section 4.3.